In today's video, I'm going to show you how I created this dynamic cast shadow on my player. We'll make it so that it only casts onto objects and sprites that we want it to, and make it modular so that we can put it on any object we want, just like this moving platform here. Okay, so looking at the general question of how can we get a shadow underneath our character, a cast shadow, if you will, and underneath anything for that matter, we need to just kind of look at maybe talk about how we might do that. So we need to be able to detect the ground plane that's beneath the character, and then, or in the case of this platform, which we'll do as well, beneath the platform, right? So we need a simple way to do that. We'll actually use a Raycast2D to do that. And then we just need to pick some sort of shadow that we can cast below us. And we'll do this in two different ways. And I'm going to show you some of the pros and cons. We could just use a sprite, which is the simplest way, or we can use a point light, okay, which is a little bit more, slightly more involved, but it has some benefits that it can bring. So let's go ahead and get into that. And let's begin. I've got a player here in my scene, and I'm just going to go ahead and add a child node to this. Let's just add a node 2D. Okay. And let's go ahead and give this node a name. I'm going to call it cast shadow. Okay. And then underneath here, let's add another node. Let's add a Raycast 2D. And then let's add one more thing for now. We'll add a Sprite 2D. And for this Sprite 2D and the texture, let's just go ahead and set this up right now. I'm going to add a gradient texture 2D. You could use an actual sprite for the shadow if you want, but if we start with this, then this is pretty versatile. It could be used with many types of games. And the type of gradient that we want, if we look at the fill, we want to do a radial fill. And I'm actually going to change this from a black and white texture, is I'm going to make it white and white, and except one of them we're going to make transparent, so it fades. And then we need to set up the fill settings on this radial gradient so that it works. We're going to say from 0.5 and 0.5, because that's the center of this texture. And then you'll notice it's kind of getting clipped on the edges there. That's because we're going to this corner position. You can see up here in the inspector what that looks like. What we want is for it to go to one of these edges, right? And you can see that should be like 1 and 0.5. Okay, that'll give us a nice smooth thing. And then we can adjust the gradient stops so that, you know, we want maybe the center of our shadow to be kind of harsh, and then it will fade out after that. Okay, so you can adjust that to your liking. And if you want to make this black, you can. The reason I don't, and this is something that you'll see me do quite often if you follow along with me, I like to leave it, and then I like to leave it white and then use Godot's modulate under the visibility. This way, if I wanted it to be a different color, it would be easy to change the color. Like if I wanted it red for some reason, you know, or just to have a bluish tint, then I could. And I don't have to go and update my sprite. I can just really quickly change the color just like that. In fact, I'm going to pick kind of a bluish dark color here. And that's going to be the shadow color. Then all we have to do really with the sprite is we can kind of resize it how we want, you know, so we can resize it just vertically like so to give it kind of that the shape that we need, and maybe make it a little bit smaller. Okay, so let's assume that is where we want our shadow to be, and we'll adjust and kind of work on how it colors a little bit later. In fact, right now maybe it's better to make this a little bit darker and give it some transparency. So we'll just drag the alpha. See, that's one reason why the modulate is super nice. Okay, so there we go. We've got our drop shadow, the actual shadow sprite. We've got a Raycast. We're going to need a script for this. Okay, so let's go ahead and in our file system, now I'm working on a kind of a demo project that I build a lot of things in. So let's pretend you're in a brand new project. So I'm just going to create a new folder, and I'll call it cast shadow. Okay, and then inside our cast shadow folder, I want to add a script, and we'll call the script cast shadow. And there we go. Let's go ahead and open that up, and let's also apply it to our cast shadow node. Okay, and I'm going to give it a class name. You don't have to, but this is a habit I like to get into, and it should extend to node 2D. And what we're going to do within this script is actually going to be pretty simple and straightforward, but we want to grab a reference to both our Raycast2D and our Sprite2D. Okay. And we want these because we want to be able to access and manipulate or change them. Okay. We're going to get data from our Raycast, and then we're going to use that to change the position of the sprite. Before we get into this code, let's review how the Raycast2D works just a little bit. So the Raycast2D casts a ray, as it says, which is just meaning a line, right, in a direction and detecting collision. And you can see that in the inspector, we've got a few settings, like if it's enabled or not. And obviously, you know, enabled is whether or not it's detecting collisions. Exclude parent will mean it won't detect collisions with the parent. We don't need to really worry about these. The collide with settings, we also don't need to really worry about these too much. If it collides with areas or bodies, by default bodies is checked. And our ground in our scene is a body, right? And I'm assuming if you're making a platformer that yours are as well. So the collision mask is important because this determines which layers it'll try to check for collision. And in the case of my game, I have layers set up. So I've got a player. I don't really need to detect collision with a player or enemies, but platforms and ground and one-way collision, I will check. Okay, so these are 3 different types of things that I do want it to check for. So you can configure yours accordingly. You know, most likely the bare minimum is just 1 layer that is used for all of your ground layers. Now there's one other important section, and that says target position. And let's go ahead. You can, when you select the Raycast2D, you see this red point. This white arrow right here is a Raycast2D, and you can see another little arrow on my player because he's got a little Raycast. We can ignore that one. Okay, and in fact, I'll drag this to the side so you can see. With our shadow, we've got the Raycast2D going down, and that is the direction and the length at which it will detect for collision. And we can control that by moving it, and you'll see in the inspector the target position is changing. Okay. So the X and the Y, this is a vector 2 that determines direction and distance. And so we don't really need the X to have anything because obviously we want it to point straight down. So the X can maintain the 0 value. And then the Y will determine how far down we want to cast it. And to start, let's just set this to 68. Oops, not 168, not 689, but 68. So that we have a short distance that it's casting. And then once, you know, the ground is further away than that, we're no longer going to detect if the player is hitting it, or the shadow. Okay, so this value is going to need to be adjusted, and I think 68 is too short. But again, this is just, or 64, I like power 2 numbers. This is just for demonstration purposes, okay? So make sure that your Raycast is configured, and then of course it can be adjusted. I'm going to go ahead and reset the transform of my shadow so it's back at the 0 of my player. And so now we're ready to work with this. So I'm going to go ahead and save those changes and go back to my script. Now you're going to see that this script is actually going to be quite simple. So as we've already set up, we've got our Raycast2D reference as well as our Sprite2D reference. And we're only going to need to utilize the physics process. So let's go ahead and set the physics process up. And the physics process, of course, is a built-in method on all nodes in Godot. So every physics tick, this is going to get called. And I'm going to put an underscore on the delta because that's an optional parameter for us. We're not actually going to be using it in this code. And if we don't put the underscore, we'll just get warnings. And so that's what the purpose of that is. And so what we need to do is we need to do the following. I'm going to make some comments. We need to detect the Y coordinate of the ground below the player, let's say, or below the, I don't know, Raycast, because it might not be a player. And then we need to, once we have that Y coordinate, we need to update the shadow position with this Y coordinate, okay? So that's what we're going to do. And it's actually pretty straightforward because this Raycast2D does kind of all the heavy lifting for us. Let's just do all of this work in the physics process and get it working here. And then if we want, we can pull it out, abstract it, and put it into its own function. But what we need to do first of all is we need to detect that Y collision point, right? So let's define a new variable. And actually, let's go ahead and do this out here. Let's just make a variable at the scope of our of our class. So we'll call a variable something like ray underscore y underscore collision point. I know that's a really long name, but then it's not too confusing what it is. And so in here, we can just say, okay, if our Raycast is colliding, because remember, we're only casting the Raycast for 64 pixels below. So there's a chance that it's not going to hit anything, right? So we need to account for that. So the first thing we'll check is if it is colliding. So if Raycast2D dot is colliding is actually the name of the function, then we'll do one thing. Else we'll do something else, okay? So if it is colliding, then here's what we're going to do. We're going to say that the ray y collision point is going to be equal to our Raycast2D dot get collision point, which is a vector2 dot y, just the y coordinate, okay? Let's go ahead and look at this. So get collision point returns the collision point at which the ray intersects with the closest object in the global coordinate system. Okay, that's pretty important. The rest of this, you can read this if you want. How I got there was by holding control and left clicking. I love the documentation in Godot. I think some people complain about it, but I think it's people who aren't familiar with it. Because in my opinion, it's really great. And the fact that it can be just loaded up in editor is also really awesome. Okay, so we're going to get a y coordinate in global position. Global position means it's the position irrespective of the position of the parent node, because you'll notice my cast shadow, for example, is at position 0, 0, but it's not, right? 0, 0 of my scene is clear up here in this top left corner. Okay, now global position is going to ignore the parent, and it's going to base it off of the global 0, 0, if that makes sense, right? Again, if I look at my Raycast and I look at the transform, it's at position 0, 0 right here, but 0, 0 in the entirety of the game world is a different position. That's the global position. And actually, it's very important to work with global positions for some calculations, because otherwise it becomes really complicated to kind of determine, well, what's the location of my parent and where am I in relation to the ground and all these weird questions. We don't want to deal with that. And if we don't want to deal with that, global position is the way to go. And as indicated by the fact that this method works in global position, that's the best way to handle our Raycast calculations. So, okay, that was kind of a long explanation, but there's one way of getting that y coordinate. Now, if it's not colliding, we can just determine how we want to handle that on our own. You could set the shadow to be at the player's feet. What I want to do is just assume that then that means the shadow needs to be at the furthest extent of the Raycast that it can be. And so we can simply detect that, and let's go ahead and do this. So ray y collision point is equal to, in this case, we want to get our Raycast2D's global position, right? Because again, we're working in global position, and get the y coordinate because we just want the y coordinate. And we'll add to this global position the Raycast2D's target position y, okay? So what that's going to do is it's simply going to give us the global position of wherever the end of this arrow is, okay? Boink, so we can just put the shadow there. This isn't going to do anything just yet, because right now, let's go ahead and remove these pass statements. But right now, we're not actually positioning the sprite, okay? We're just calculating. But for the sake of demonstration, let's go ahead and print this to the output. Let's just go ahead and print our ray y collision point. And let's run the project, see what happens here. So if it's working, there we go. 231, it's just printing that because the ground is at that position. But you can see as I go in this little dip, the number changed a little bit. And if I jump up here, there we go, 167, that's higher. And then let's hit this platform. Oh, okay. No. Ah, dang it. Boink, 140. So you can see it's definitely detecting a different Y position, 135 for this piece of ground, okay? Obviously the shadow was sticking to his feet, and that's not what we want, but we've proven that we're getting a collision point. So let's go ahead and use that information next to move the shadow. Okay, so we've already left a comment here where we want to update the shadow position with this Y coordinate that we've detected or calculated. So this is also quite straightforward. We just need to grab our Sprite 2D, And then we need to adjust its global position. So we're going to say Sprite2D.globalPosition.y, because again, we only need to adjust the y coordinate. The x is fine. We'll leave that as is. Equals, and we can simply set it to this ray y collision point, because since this is already in global space, if we set that globally, then it should update. So let's just run that one more time, and it should be just automatically working. Let's go ahead and make it full screen. Okay, it is working. You see how it's staying stuck to the ground? You'll notice it's coming up just a little bit, but in general, it's working. There we go. When I jump up here, go down there. Okay, so the reason why it's coming up with the player when we reach a certain height is because if you remember, we set our maximum distance pretty short. So once the player is further than that 64 pixels above the ground, then the shadow is going to move with the end of the arrow. Okay, so I think that demonstrates the general principle of how this is working. So if we go back to our script, we can adjust this. Now, this is actually something that I think is kind of cool. One thing that I think is fun is just adjusting the opacity of that shadow, making it more transparent the further we get from the ground. And so we can do a real quick calculation to do this. And what I want to do here is let's just take our Sprite2D, and then we can say modulate dot a equals, and then here we need to kind of calculate it, right? We need to calculate, we want to fade this in and out. And so we can use this simple little formula here where we take our sprite. In this case, we're going to use position, not global position, right? But you could use global position, but I think in this case it makes it easier because we do know that the position is going to be in relative to 0 always, okay? And then we just need to divide this by whatever the maximum distance that it can be. And right now that's 64 pixels, right? That's how we have that set. And we're going to subtract that from 1.0 because what this formula is going to give us is it's going to give us a number between, oops, I didn't put .y. I needed to put position.y. This is going to give us a number between 0 and 1. And we're going to subtract that from 1. So the further we are from the ground, the lower this number becomes. And just to be safe so that we don't get a number outside of like a negative number, because I don't think we can handle that, we can kind of clamp it. And one way we can clamp this is just saying maximum, like that. And let's go ahead and look at this. Max returns the maximum of given numeric values. The function can take any number of arguments. So we're just going to say this and 0. So that if it's less than 0.0, then this 0.0 becomes the max, the highest number. This is a real simple way to kind of clamp that. Okay, so let's go ahead and run this, and it should fade the shadow out if I did that right. Okay, there we go. You see how that's fading away? And now if we jump higher than that, it doesn't matter anymore because we no longer see the shadow. Okay, that's one way of handling it. And I think that's my preferred way of handling it because I also like the fade effect. But we should adjust this. Let's make this so that this fade effect is a little bit more dynamic, and we can increase the distance at which we can cast our shadow. So let's go to 2D, and I'm going to just grab the cast shadow here, and let's see, or not that, but the Raycast. Let's double the distance that we cast to 128 pixels. Okay, so quite a bit further. And now at this point, I mean, if I move my player around, right, you can see the bounds of my screen. If I move my player to the top of the screen, he's going to be, I mean, he has to jump that high before the shadow fades. I think that's probably okay. I mean, you may want to go further, and if you want to double this so that you do, you can. Technically, the Raycast becomes more expensive as the distance increases, but for the sake of a 2D game like this, I don't think that that's a huge concern. Okay, so I'm going to come in here, and so instead of hard coding this to 64, I think we could just use a Raycast position.y if we want, and that's going to be whatever that number is. So we can do that. So then if we adjust the Raycast, it should adjust. So let's go ahead and run one more time. And now you can see it's not completely fading because we can cast from a much further distance. Let's jump on this platform here, and then When we jump off, whoop, so you could hardly even see that. So that's a pretty good distance because generally the player is not going to be much further than half the screen from the ground because of the way the camera works. So there we go. We've got that set up. What we're going to do is we're going to improve the quality of the shadow and address a few issues. And the issues that we're going to address here are the following. So the first one being that the shadow is on top of the player's feet. That's not cool. We don't like that. And also if the player is kind of going over a ledge here, oh, look at that. It's hitting the ground down there. If the shadow is going over a ledge, I don't really want this shadow sticking out above the, in the air like that. Okay, so we're going to fix that issue as well. Now, the issue with the shadow being on top of the player, in the case of a platformer or 2D game like this, can generally just be fixed by adjusting the visibility, the ordering of this Sprite 2D node. So if I were to come in here and just set the z-index to -1, you can see that took care of the problem right away. The only catch is you have to make sure that you don't set it to a z-index that puts it behind the ground, which I didn't because I happen to have my ground at a further layer back, I think. Alternatively, let's try this. I think what we can do is say show behind parent, and that didn't work for that, but let's go to this cast shadow as well. In fact, let me just uncheck that. Let's see. So if I go to cast shadow and I go to visibility and I say show behind parent, there we go. So now this whole node is going to try and render behind the parent. And this is probably a preferable way for this node since we're going to be dropping it into other nodes. Just say show behind parent and that should be good. Okay. That fixes one issue. That's an easy fix. The other issue is not so straightforward, right? And that's the one where it like sticks out over the edge here. So what we need to do with that is we actually need to change what we're rendering. So a Sprite 2D, I'm going to go ahead and just drag this to the side. A Sprite 2D is not the thing to use if we want to clip it, in my opinion. There's actually a far easier way to do that, and you could get really complicated, but what we're going to use is a PointLight2D. Okay. Now this PointLight2D, let's see, what's the warning here? We need a shape, which we can do. We'll go ahead and I'm going to take this texture 2D. I think I can just copy this. Is there not a copy? Oh, there it is, copy at the very bottom. Now let's go to our point 2D, and under texture, let's paste. Okay, there we go. So we've got a light, and you're probably thinking, what the heck? That's a light. That's not what we want. We'll get there in a second, but first let's just resize this so that it kind of matches our shadow. Okay, and by the way, I'm holding Alt to keep it scaling from the origin instead of from the sides. Okay, so here we go. There's our new shadow, which right now is light. And I mean, you might think make it black, but that's not, that is not going to make it work. But what we can do is we can change the blend mode from add to subtract. There, now it's like a shadow, right? And we'll just decrease the energy maybe. I'm going to set this to 0.5. And we can change the color if we want, but we'll just leave it white because once you do subtract, it's kind of inverse. So if you want a color, you got to pick the opposite. But anyways, there we go. We've got our shadow. Let's real quick go into our code because this is manipulating the Sprite 2D. So we want to actually bring our PointLight2D in, and we can just copy and paste these. Well, let's copy and paste this first line actually. So right now we've got a Sprite 2D. Let's change this to be our PointLight2D, and we'll set the global position. And then instead of modulating our point light, we can actually adjust the energy. So we'll say PointLight2D dot energy. And then we could use this same we could use this same kind of function to determine the energy. So let's go ahead and run this. Okay, so we've got two shadows. The one on the left is the light, and the one on the right is the sprite, okay? And you can see with that, the code is working to fade the new one. Let's see what happens up here. And actually, this is going to be hard to demonstrate, maybe, but you can see when the shadow sprite is overlapping, it looks like that. But if we overlap this light, oh, actually, yeah, it's still doing what we don't want it to do, isn't it? Okay, so this is where it gets slightly tricky, okay? So if you bear with me real quick, let's go back to our 2D view. And in our point light, we can go down to the visibility, and we've got a light mask and a visibility layer. Okay. So these settings are what we're going to use here. This is the light mask. Technically, I don't think we need a light mask for this layer because it is a light. The visibility layer, we can turn it off and turn it on to a different layer, right? And you're probably thinking like, oh, okay, what good does that do us? Well, let me just look at one of these tiles. So if I have this ground here, okay, and I look at the way I've set this up under visibility, you can see that I have it on light mask layer for layer 1 and layer 2. Okay, now this one in the back, I probably should take that off layer 2. Okay, so the plants don't have that. And I've probably got a few other nodes that I need to adjust in a similar fashion. I didn't think about this beforehand, but this is good because this is, there we go, background. This background layer is a tile map. Let's just make sure that it's visibility. Yeah, only light mask for layer 1. Layer 1 is just consider that like our primary light layer. Turn that one off, layer 2. I've got a couple of these, so just bear with me while I go through real quick. And these are all on because I copied and pasted the tile maps. And so that means I, copied and pasted the light mask settings as well. Okay, hey, look, that last one is a sprite. Okay, so now I've turned those off. And if we've got this right, and I go to my player, it doesn't seem like it's right yet. Let's see. Ground back. Oh yeah, so we need to go to our light. I guess we didn't configure this yet. So what we need to do is actually the visibility is not what we need to control for the actual light itself. Let's go, what we need to do is under range, turn off layer 1 and turn on layer 2. Okay, so that disappeared, right? Because these bushes are only on layer 1. Now, if we move our player though, down here, oh, there you go. You see how that shadow is showing on the ground layer because the ground layer has the setting for it to be on layer 2, right? If we look at this, it's get the light mask for layer 1 and 2. So this can be lit by both layers 1 and 2, while as the other things cannot. And if we look at back to our point light again, just to take this full circle, we've got things on layer 2. Okay, so let's just run this one more time. And now this is going to work different than when we demoed it the first time. Okay, so let's come over here to our handy little edge. Okay. Oh, I've got a problem. I've got another problem. I guess I've got this ground back layer. It also needs to be light mask layer 2 because it contains these platforms. My bad. Okay, let's run this one more time. Okay, here we go. So now it should work. Boink. So you just need to make sure all your tile maps are configured properly. But now when I come to the edge of this, it's actually maybe kind of hard to see because of this dark thing, but you can see that the shadow gets cut off right on that edge. Okay. I don't think we have this thing set up to work with either of those, so we'll do that in a second. Let's see if I can get over to this other taller platform. I think it's a better example. There we go. Yeah, so you can see how that shadow is getting cut off because it's only lighting this part of the sprite. Okay. So that's how we're going to make this shadow work, and it's going to look a lot nicer. So we can go ahead and go into our cast shadow. We can remove this Sprite 2D, take our point light, and let's just go down to transform and reset that to the center. Okay, so that's where it is. And then go into our script here, and anything related to the Sprite 2D, let's just remove that from our code. So remove the script in the physics, and then let's also remove this onReady reference to the Sprite 2D. And, oh, look at that. I was using the wrong position here. So let's go PointLight2D, position Y. And actually, if we wanted to, we could, so we could decrease this. Like, I don't really want it to get fully opaque. So there's two ways we could handle it. We could adjust this from 1.0 down to something like 0.9. Alternatively, we could come into here, since this is a light and we're modulating it, we could also make the light kind of a gray color so that the darkest it gets is something like that. Set the energy to 1. There we go. Now we can see what it looks like. Okay, so I'm going to just drag this till it looks good. So when the player's on the ground, it's going to look like that. Let's just run this and make sure everything looks good. Okay, looks pretty good. You might want to adjust the shape of that shadow, but there we go. Okay, so a couple last steps that we can do here is make it so that it works with this platform, and we're going to show you something else that's fun. So real quick, we should turn this cast shadow into a reusable node. Okay, so I'm going to right click on the cast shadow, and I'm going to find the option. It's called Save as Scene. Save branch as scene. Okay, and then let's just navigate into our cast shadow folder, and it's already named cast shadow because that's what I named the node. So that's good. We'll go ahead and save it. Okay, so now this is a scene, right? And it's all in here. And that means it's reusable. So what that also means is we can just make a copy of this scene and put it on my platform, for example. Okay. And then because I did that, let me make sure that the transform is at, yeah, see, it kept the same position. Let's reset that to 0, 0. So now we've got a shadow right here on our platform. I'm actually going to drag it so it's below this. And then I'm also going to select my sprite on my platform and go to my visibility and turn the light mask on for layer 2. There we go. Now you can see that shadow's there. So what's really cool about this is this new node that we've created is super modular. So now you can see there's a shadow beneath the platform, and it's just that simple. You can just drag and drop this shadow onto any node that you want to use it on, and it'll just work. Okay, I mean, you could adjust like the way that you detect how dark it is, you know, that fade, that energy calculation that we do, so that it doesn't fade out as quickly. And you could change the color, you could do all sorts of things, and you can just drag it and drop it. So you get an enemy, just plop one of these nodes on it, you know, and it'll just work. So today we've learned how to make this handy little cast shadow. I hope you guys have learned something new. Please give me a thumbs up, like this video if you think it was useful, and leave some comments as well if you've got comments, questions, or if you run into any issues, and hopefully we can help each other to solve them. You can also subscribe to my channel. I've got a really long-running action RPG series going right now that I focus on primarily, and then in between I'm doing videos like this. So go ahead and subscribe if you want to see that or see what's coming next. And I appreciate all of you for watching. And as always, we'll see you next time.